In this video, we're solving a trigonometric equation, and the problem says, find in radians all the values of theta in the interval 0 is less than or equal to theta is less than 2 pi that are in the solution set of the secant of theta times the cosecant of theta plus radical 2 cosecant of theta is equal to 0. Well, there's a couple things to keep track of here. First of all, it wants us to give the answer in radians. And you're welcome to do it in radians if you're comfortable with that. I think for this video, we're going to do it in degrees, and then once we have the solutions that we want in degrees, then we're going to convert those to radians. Okay? Also, notice that in this problem, it isn't just one trig function. There's a secant and there's also a cosecant. And when that happens, you either have to find a way to change one into the other, or hopefully you can factor. And in this problem, that's exactly what we're going to do. We're going to try to factor. So, is there a greatest common factor of this term and this term? What do you see in both of those? I see a cosecant of theta in both of those, so I'm going to factor that out. So this is the cosecant of theta times, what do I have to put here so that the cosecant of theta times this becomes this? I have to put a secant theta there. So this is the secant theta, right? Because cosecant theta times secant theta will give you secant theta cosecant theta plus what has to go here so that this times this will give us this. You're right, this has to be a radical 2 is equal to 0. Very good. The reason this is good is because each of these separately forms their own little equation that only has one trig function in it. So this is the cosecant of theta equals 0 is one possibility, or the secant of theta plus radical 2 is equal to 0 is the other possibility. So let's see what we end up with. The cosecant of theta equals 0. Well, there is no button on the calculator for cosecant, but that's okay because the cosecant is nothing other than 1 over a sine, right? 1 over a sine is the same thing as a cosecant. So what we can do is think of this as being like 0 over 1, and we can try to take the reciprocal of this. So if the cosecant of theta is 0, that would mean that the sine of theta must be the reciprocal of that, which would be 1 over 0. And here we say, do you see why this is a big problem? You can't have that. And so this is just saying that there is no solutions on this side. You can't divide something by 0, so there are no solutions here. How about over here? I'm going to isolate the secant theta first. So we are subtracting radical 2 from both sides. We end up with secant theta is equal to negative radical 2. We don't really like to work with secant theta, but no problem. Secant theta is nothing other than 1 over a cosine theta, which means that if I want to change it to cosines, that's the cosine of theta is equal to the reciprocal of this. The reciprocal of a negative radical 2 is a negative 1 over radical 2. We prefer to rationalize our denominators, so I'm going to multiply the top and the bottom by radical 2, and we end up with negative radical 2 over 2. Now, this should be familiar to you. You have seen radical 2 over 2 before. In fact, I can tell you, because you ought to know, the cosine of 45 degrees would equal a radical 2 over 2. That's not a negative radical 2 over 2, but it should tell you that somehow the angle that we're working with is related to 45 degrees somehow. Okay? Let's go ahead and, let's see if we can find that by using that idea of a reference angle. So here I'm drawing a unit circle. We know where radical 2 over 2 is, right? If I draw on the 45, this is 45, then the coordinates of this point at 45, that's radical 2 over 2 and radical 2 over 2. Right? The cosine is radical 2 over 2. Where is this going to become a negative? Well, it's going to still be positive here. The x-coordinate will still be positive here. the x-coordinates do become negative here and they become negative over here, right? So let's draw in the angles here where that happens, right? Of course it happens here, so the coordinates of this point is negative radical 2 over 2 and radical 2 over 2, right? What is the size of this angle? Well, this must be the 180 and then minus the 45. And so that's 180 minus 45, which gives us 135. So one possibility is that theta is equal to 135 degrees. But since this is a cosine, we have to also reflect across the x-axis here. So we reflect this across the x-axis. And since this is 45, that means that this must be 45. So this is 180 plus 45 more. So that's 180 plus 45, which gives us 180 plus 45 is 225. So these are the two answers. These are the two solutions in degrees. Of course, we would like to give the answers in radians. So this is just an opportunity to practice converting from degrees to radians. So to convert 135 degrees to radians, I multiply it by pi over 180, right? Because that's degrees and this is degrees down there. The degrees cancel out and we're left with something in radians. So this is 135 pi over 180, which can be simplified. I'll show you a little trick for simplifying this on the calculator. That was 135. This is 135 over 180, right? So I'm just going to put in 135 divided by 180. Hit enter. There's the decimal. Hit math. Enter, enter. It says that that's 3/4. And so this is simply 3 pi over 4. See, this is 3/4, so you have 3 pi over 4. That's one possibility. Now let's convert this 225. So 225 times pi over 180. That's going to be 225 pi over 180, which becomes, well, let's reduce that 225 over 180. So this is 225 divided by 180 gives us this value. We hit math, enter, enter, and it says that that's 5/4. So this is 5 pi over 4. And these are the only two answers because we were looking for values that are between 0 and 2 pi, which means we're not going around the circle more than once. And so our answers in radians are right here. I'll put them all together. In fact, I'll put them right here. We can just put them right here. This is the same thing as theta is equal to 3 pi over 4. And theta is equal to 5 pi over 4. And these are the two and final answers.